Welcome to the Startup Defense. My name is Callye Keen. Today I have Ed Mehr. Now, Ed, you're doing something really interesting in manufacturing, and you've made a name for yourself in defense as well. And I really want to get into talk about reindustrialization, new manufacturing techniques. What does that mean for America? What does that mean for making cars, boats, subs, and all of that? Before we jump in and talk technical details and overcoming obstacles and inventing a new way to form up metal, same question I ask everybody. What are you passionate about right now?
Well, I mean, at core, I'm passionate about building, right? I was always a builder since, I was a kid, learning welding, carpentry, later on started building custom cars. So I'm always passionate about building. And I think this is like, it has never been easier to build. I think when I look at the past with, 3D printing, with our technologies, now the idea of going from a design to a product to a physical part has been easier than ever. I am really excited about that. I think with robotics and artificial intelligence, we are this like nexus of enabling something new, a machine that can build other machines in an intelligent way. So that is really what excites me. AI, kind of showed us that we are kind of, can do crazy things with computers, things that only humans could do, but yet haven't yet, kind of like stepped into the physical world, right? In the virtual world, you can create images, you can create all kinds of text and do research and create virtual content. But I think we're right on the early stages of unleashing this power with robotic into the physical world. So I'm very excited. Honestly, like I wake up every day and I'm reading news and I'm reading the latest research papers, and I'm like, oh my god, it's like such an amazing time to be alive, and the opportunities are endless. Most of the days I just can't contain myself, like looking at all the stuff that are happening, and I'm like, okay, it's exciting time to be part of this.
We're totally in sync on this. There's always been this conversation around skills gap or who has technology and who doesn't. But now there's this big resurgence where new smart people are entering the market. And hey, robots are really cool. Manufacturing is really cool. Building things is really cool. And so all these new smarts and new capabilities, and then you couple that with new sensing technology and AI and new software technology, and you're at this, I think, catalytic inflection point for total reindustrialization of the supply chain from critical minerals to processing to forming metal and machining metal and building large systems. I too am excited about this every day, and this is why I was so excited to talk to you. First, I do really want to get into this thread about reindustrialization and getting smart people to work on hard problems. And I do want to just dial it back a little bit and focus on Machina Labs. Like, what is it for people who don't know who you are and what you're up to? How did you arrive at that idea, and why did you pursue that and what is it?
Yeah, no. The vision, really, the vision at Machina Labs was about what we actually said we're both excited about. Can we build a factory that can turn our intentions into final products as most efficiently as possible and as fast as possible? As you know, a lot of times today, if you want to build a physical product, you have to build a factory for it, right? A factory, Elon Musk has famously said, the factory is the actual product, is the product, right? Because once you have the factory that builds cars, the car part and selling it easy. It's like it's the making the cars that's tough, and it's the main product work. And that to me is now has turned into a bottleneck. The fact that products are tied to the factory and the factory cannot change easily to make a new product. It's the bottleneck. So our goal at Machina is to build a factory that can make car parts in the morning and then switch and make missile components in the afternoon, and at night where nobody's even there can make aircraft panels. We started from metal structures specifically, out of the manufacturing. We focused on the structures and specifically on metal structures. And our first kind of area of work was sheet forming. So we wanted to build a system that can easily turn a design of a sheet, a complex compound curvature sheet of metal, into a final product without any hardware specific tooling, molds, geometries that are tied to the material, tied to the geometry that you're trying to make. So we're building these robotic systems. We call them robo craftsmen. that, turns a design into a final product by working at it like a human sheet shaper would do it. A human sheet shaper come in and hammers a sheet slowly into shape. It doesn't require a die. We're doing the same thing basically with robots. Robots are incrementally deforming a sheet into shape. That's where we started. But since then, we have added other operations to the system. So we now do trimming as part of RoboCraftsman. We do a lot of subtractive process, hole making, slotting, things like that. We have QC, so we can actually generate QC reports, look at what the robot did and compare it to the design and tell you, okay, how well you have done. And then also use that data to learn how we can improve our process. We're working on heat treatment on the system. We're working on forging. We're working on adding additive and welding and assembly. So we're constantly adding more operations to the cell. So the idea is eventually you can have a facility and you deploy 200, 300 of these into that facility. And this whole facility is software defined. This whole facility can be programmed to make missile panels and then switch with just a change in the software to do aircraft panels. And we are actually that dream is already happening in one of our facilities. Like we are manufacturing defense components in our facility number one, who has 8 of these systems running and making components. We're about to start our facility number 3, which is going to have more than 50 of these systems running in parallel and actually gives us throughput. We can do thousands of metal structures, advanced metal structures for defense applications a year. And facility number 4 is also in the works. So, the goal was, going back to what we started the conversation is like, can we have a factory that does what we were both excited about, can turn our intention, our design into reality as cheap as possible, as fast as possible.
This goes back to your core thesis that I read is America doesn't have a design problem. We have a factory problem. It's a good summation of that?
Yeah, absolutely. I think, you mentioned, I think manufacturing always was cool, right? What we ended up doing was it's one of the most fundamental ways we express ourselves in the world. Like, people write poetry, people draw paintings, but one of the main ways we actually were expressive, which I think at the end of the day is what every human wants to do, wants to be expressive and, give the world what they're uniquely their form of expression. But one of the biggest categories was expression in 3D world, building physical things. I think a few decades ago, we decided, and I think it's mostly was decided by finance people that, and rightfully so, they're like, in this whole chain of creation, the valuable parts are the IP and the design and maybe the distribution. You need to have the brand to distribute it. Everything in the middle is low value add, right? And economically maybe was so. And then we ended up deciding to like outsource this to other countries that maybe were, it was cheaper for them to do that component. But I think we soon realized that, hey, like there's something fundamental is now missing from our society, not from a practical perspective, because from practical perspective it's also that way, right? Like right now China can pull the rug from underneath us and we don't have any way to manufacture the things we need, but also from the perspective of like now we're not touching hardware and metal anymore. We're not in touch with reality anymore. But I think it was always cool. We just like decided that some of these portions like we don't want to touch for a while, and I think it was a mistake.
Yeah, I think it's fun. It's funny to me to see people making this realization that, manufacturing is the lens that focuses and creates innovation. It's the gate that all innovation has to pass through. So if you own the gate, if you own manufacturing, you own innovation. We see IP theft issues, sure, but we really see this readiness of this supply chain of ideas to reality is disconnected because manufacturing is the foundational element that allows the realization of those ideas. So from this extended standpoint, yeah, I think all human beings want to be a creator. And for me, there's this singular experience of having an idea and then seeing it and holding it in your hand that really is incomparable. The By moving that away and saying like we can do higher value tasks, then we erode our capability of actually in the long term realizing those wonderful ideas that everybody has.
It was an oversight, and I think we only thought about it from financial perspective, and then we ignored all the strategic components of it, all the actual psychological component of like, if you're not building, what kind of society are you creating? If you're not dealing with physical constraints to the material. And then I think the societies who took on that challenge, we see that they flourished, right? That they not only learned that really well, but then to your point, they started also coming into the IP portion and coming to the distribution portion. And we're like, oh, like, nothing prevents them now to also come to these higher value add areas once they own one of the most important parts of the process.
Yeah, I think in a very non-abstract way, if you own the pipeline towards building, you essentially own innovation. Or to clients, I ask, like, if you don't know how your product gets made, do you really have IP?
That's right. And it's funny. And a lot of your IP, I mean, back in the day, I remember we would like work with like some of the countries in Southeast Asia. And, your IP is basically at this, like, you make a product, your tooling, your design, all sent to those countries. Like, okay, so, well, you just made it and handed to them. Right. And so they have it. Even if they don't want to be malicious, now they're learning from it. Right. So, yeah, absolutely.
Yeah, yeah. And so it contributes to this overwhelming human capital component, which I think the move towards software defined manufacturing is really interesting because you can pull in a lot more people under that tent of contributing towards manufacturing. So smart software people, smart robotics people can then contribute to what we have this conversation pretty often is that the perception of manufacturing is still like smokestacks and pouring acid into rivers. And then people will come over and visit me and they're like, there's robots everywhere. You're doing this, you're doing that. I'm like, you can go to any of my friends' factories, quote unquote factories, and you're going to see some of the most advanced technology on earth making other advanced technology. But the perception of this is still quite skewed. But when I look at Machina Labs and you see those two robots forming the sheet, it's like, who wouldn't want to come up with an idea and play with that? And that gets me excited because even that picture or that video, even if I don't understand how sheet forming works or deformation, it's exciting enough where somebody is going to think that it's cool and want to get involved, right? And by extension, I wrote a paper, it's supply chain as a deterrence, because I think that again, in a non-abstract way, your ability to produce infers your ability to respond. So instead of thinking like we're going to stockpile munitions, we can stockpile the human capital and the factories to produce more planes and tanks. But we don't actually have to produce those items. We just have to have the ability to produce those items. And when I look at what you're working on and it being reconfigurable, this is something it's highly desirous. Like I want to talk about like how does this play into defense readiness, or this Freedom Forge 2.0 is like we're making John Deere tractors and then the next week potentially we're making John Deere tanks. Is that like a non crazy thing to say?
No, I think that is the future, right? And to your point, it's not even just about defense. I think, the future where you have variety of design and speed and delivery and execution is the future that I think we're going to see across all hardware products, right? Any sci-fi movie you look at, and I'm going to come back to defense, but to your point, you said something that really resonated in terms of like make it attractive for the talent. If you look at any sci-fi movie, every building looks different, every car looks different. There are like spaceships that all look different that are in the space. There's this explosion, huge design variety. Today, we can't do that. So I think the future of manufacturing will look really agile, really fast, but also like high variability. But to your point, if you come back to today, and that's by the way, exciting future that a lot of people want to be part of, right? Enabling, another thing that's happening with the AI, a lot of this white collar jobs are also to some extent losing their value a little bit, that the value they used to have. So I think we're going to also see this resurgence of blue collar, but it's not going to be as blue as before. It's going to be actually working with iPads and robots and laptops and programming things, right? So it's almost like humans that have extensions of themselves, both intellectually with AI and with robots physically, into a shop floor and are doing things. So I think we're going to see a resurgence in that type of a work, and I think that's going to be the cool type of a work in the future, and not so much of this future, even today in the next few years. But to your point, you talked about agility. I think in defense, that agility literally turns into advantage. I was tempted to say factory, and one of our new factories that we were deploying, we were like looking at some artwork that we wanted to put on it. I was tempted to say factory is the weapon, right? Because it is like the actual war is happening in the factory. Good example of it is when we started getting conflict, Ukraine got in conflict with Russia, and now we are seeing the conflict that we have in the Middle East with both Israel and Iran. We started seeing Iranians and Russians using the Shahed drone, which is now the famous drone, right? That a $40,000-$50,000 drone that, we needed $2 million missiles to hit it, right? In this setting where the adversary is coming up with these new weapon systems that we have never seen and they suddenly show up in the battlefield, how do you win battles? You win battles by reverse engineering that or making a better version of what they had as soon as possible. You cannot go and work in the factories for 7 years and design and build the plant and then eventually be like, okay, I made a new drone. Right now everybody's copying Shahed, but I think actually almost it took a while. It took a few years before we copied what Shahed and Iranians did. Now we have the Lucas drones and all these drones that the US is investing in. It's at early stages of it, while Iranians were using this in battlefield in Ukraine a few years ago. So really the advantage is turning into how fast can you respond to enemy and how fast you can go from a drone that goes 1,000 miles to 2,000 miles by just through changing in the wing configuration, the design of the wing, and a few other design elements to be very rapidly responsive to the battlefield conditions, right? That's what's going to give you advantage. The advantage of those bespoke weapons, $100 million fighter jets are still there, but it seems like we're moving more toward this world where rapid agility and agility toward responding to what the enemy does in terms of manufacturing is becoming more and more important, and it's becoming a strategic advantage for defense.
The first run up with additive manufacturing, 3D printing, like 2010, 2014 range, people were really excited about additive. And this was their conversation. People would come into my shop and be like, how much longer are you going to use CNC machining? Because soon you're going to be able to just say, hey, I'm 6 foot tall, so I'm going to customize this for me and it's going to print out a widget, right? We are dangerously close to understanding what that tool chain might actually be for inputting a new requirement, reconfiguring a highly engineered product like a drone, changing the wing configuration, changing cable harnesses, changing the engine, changing the integration, and then being able to set those manufacturing processes in motion. And I think about this all the time because in 2010, the idea of 3D printers just going and replacing everything, it is totally ridiculous, right? And it is a ridiculous proposition. But to somebody who's not in manufacturing, they see this like magic black box, and like it's like Star Trek. It's my like replicator, right? And that will never happen. But then looking at it as this software defined factory or network of factories and suppliers to ingest new requirements and then adjust and produce, I think is really interesting. But just across defense, the issue for a lot of really critical and essential systems is the volumes are so low that the most efficient way to make them can't really be built. You'd have to build a very large factory that's bespoke to something that is only in volumes of hundreds, if not just like dozens a year. And it makes no sense to do. Whereas you think of like a new radio to then I need 10,000 of these radios. If that tool chain is software defined, it really doesn't matter if it's customizable and it's going low volume or high volume, right? Because the switchover capacity is there. And that I think is an undersold point about flexible manufacturing versus the reactive to new requirements field. Like I understand that and we see that playing out in Ukraine, but just the I want world-class manufacturing, but I only need 50 of this very specialized item ever. And then I need 50 of a different one next time. It's very hard to spin up a world-class supply chain to make, you know, very low volumes sporadically
Yeah,
and under non-multi-year contracts, which is it's kind of the bane of manufacturing and defense, right? Is
totally. No, I agree. And I think,
ability.
there was, I think when 3D printing came about, and I was in 3D printing before we started Machina, I was at Relativity, and we wanted to 3D print launch vehicles, right? Like rockets as much as we can. I think 3D printing, had this both a pro and a con, right? I think the pro was I think it started to make it seem possible, right? That world that you described, the high mix world is actually within reach, right? But I think that the reality check of that was, to your point, is that like, hey, well, not everything's going to be 3D printing. And I think that's true, right? I think 3D printing is one of the tools in the tool set. The CNC is one of the tools in the tool sets. Roboforming, what we're doing, is one of the tools in the tool sets. 3D printing opened up that imagination, but I think it opened it up too wide that people like relied on it too much for a little bit. I think now we're kind of coming back to reality. I think what will look like is going to be 3D printing and 10 other different methods that are also as agile as 3D printing coming together. Use the right method for the right part. When we were building missile components here, I roboform our process, roboform the, let's say, skin of a fuel tank or a skin of a missile. I machine the ribs and spars. I machine the bulkheads, right? And then I still need a very flexible joining solution, like a robotic laser welding, to put it all together. If I have an engine, I need 3D printing, right? Like, because it's a heat exchanger, and the best way to do it is probably through 3D printing with a lot of internal features. But all of these three methods that I talked about, from roboforming to machining to 3D printing to robotic welding, they're all very flexible and very small tooling requirements. So now if I have a facility that combines all of these things, now we have a pretty much a software-defined factory, right? We can easily switch from one product to another. 3D printing gave us the view, but I think it was just a start, right? We need all these other processes also to mature and become flexible, to have a factory that can actually make useful parts, and still, to your point, makes 50 of one product and switch to another product, and make 50 and then still stay very cost competitive, and not each product shouldn't cost like hundreds of $1,000s or $1 million to do, right?
And before we go, because you've worked in such a capital intensive and difficult space, I wanted, just if you have any words of advice for potential founders that are listening, or founders, like, manufacturing and defense is like, you've accumulated all of the merit badges, there's all the capex costs, and you've done well. So like, any insights or word of advice for somebody that's looking to enter manufacturing and be an innovator and launch a startup, like, lessons learned?
Yeah, the biggest lesson is just do it. You're going to learn a lot by just doing it. I think it's a new area of company building. We used to have industrialists back in, where your family started your company in the defense side, right? A lot of focus on the new companies have been focused on software. So I think a lot of people have lost that understanding of what it takes to build these type of companies. So there's a little bit of relearning that. I think a lot of people who are building companies think about venture capital right off the bat. I think that's a good way to get started. That's a very good way to develop some of the early IPs. But I think you need to be much smarter than just one source of capital. You need to start thinking about how the government can help. How can your customers be part of the solution? Like, how can you fund the project through your customers? How can you, work with banks, loan, and other types of financing like debt to finance your fixed assets and your capex, to your point, right? How to be smart about buying capex that is actually attractive for debt financing, and it has, some kind of a resale value. So there's this different mix of problems that you need to solve than a traditional startup. But I think you only learn it by just doing it. So I would say jump in, but it's an exciting place. Like, I think at the end of the day, I think I worked in software companies in the past, and the satisfaction you get, to your point, of holding a part in your hands and be like, hey, this used to be in my head and now it's a physical thing. It's immense, and it's very rewarding. But yeah, there's a lot of new skills to learn. And if they want to reach out to me, I'm happy to also to help, on social media or on LinkedIn and Twitter. I'm happy to help anybody who wants to step into this area.
And again, I really appreciate you taking the time to be on the Start of Defense.
So thank you. Thank you for having me. I had a good time, had a good conversation.
My name is Callye, and this has been the Start of Defense.